July 16, 1969. A rocket stands on a launch pad in Florida, taller than a 36-story building. Inside, 3 men, strapped into a capsule no bigger than a minivan. Their destination? The moon, 238,000 miles away. No GPS, no modern computers, just physics, engineering, and human judgment. This is Apollo, and this is how it actually worked. Apollo wasn't one spacecraft, it was a system. 3 separate machines working together perfectly. At the very top, a small escape rocket. If something failed during launch, it would pull the crew away in seconds. Below that, the command module. This is where the astronauts lived, worked, and eventually came home. Attached to it, the service module. Engines, oxygen, power, life support, everything needed to survive in space. And hidden beneath, the Lunar Module, the only part designed to land on the moon. All of it sitting on top of a single machine built for one purpose: to leave Earth. The rocket had 3 stages. Each one burned fuel, then dropped away, dead weight, gone. Stage 1 ignites, 5 engines, each one incredibly powerful. Together, they produce more thrust than any rocket before or since. For about 2.5 minutes, it burns through massive amounts of fuel. Then it shuts down and falls back into the ocean. Stage 2 takes over. Now above most of the atmosphere, it pushes harder, faster, higher, until the edge of space. Then, final stage, 1 engine, precise, controlled. First, it places the spacecraft into Earth orbit. Then, after a short pause, it fires again. This burn sends Apollo toward the moon. No turning back. Now, something critical happens. The command module separates, moves away, then slowly rotates 180 degrees. It docks with the Lunar Module, still hidden inside the rocket stage, locks in, then pulls it free. If this fails, the mission ends here. No landing, no safe return plan. Once complete, the empty rocket stage drifts away. Apollo is now alone on a path to the moon. Inside the command module, 3 astronauts, surrounded by switches, hundreds of them. Every system is manual. Every action matters. Beneath them, a heat shield, designed not to resist heat, but to burn away, to carry heat away from the capsule. Behind them, the service module. This is where survival happens. Fuel cells generate electricity. They combine hydrogen and oxygen, producing power and drinking water. At the back, a single main engine. It must work. There is no backup. If it fails, they don't come home. The Lunar Module is different. It was never meant to fly through Earth's atmosphere, so it wasn't built to look smooth. It was built to work. 2 stages. The bottom for landing, 4 legs, a controlled engine. It can adjust thrust, slow down carefully, hover if needed. The top for leaving the moon. A small cabin, no seats, just enough space to stand. When landing is complete, the bottom stays behind. It becomes the launch pad. Then, at the right moment, the top half fires. 1 engine, no backup, but the fuel ignites instantly on contact. No spark needed, no delay. It lifts off, rendezvous in orbit, reconnects with the command module, and the mission continues. Out there are no roads, no signals, no landmarks. So how do you know where you are? You look at the stars. Inside the spacecraft, a sextant. Astronauts measure angles between known stars, feed that data into a computer with extremely limited memory, but enough to do the job. On Earth, large antennas track the spacecraft, measure tiny changes in radio signals, speed, distance, direction. Between human observation and ground tracking, they always knew where they were. Coming home is the hardest part. The capsule hits Earth's atmosphere at extreme speed. Air compresses in front of it. Temperature rises to thousands of degrees. The angle must be exact. Too shallow, it skips away, lost in space. Too steep, it burns. The heat shield begins to break apart, layer by layer, pulling heat away, protecting the crew. Inside, the force builds, heavy, relentless. Then, parachutes deploy. Small ones first, to stabilize. Then 3 large ones. They slow the capsule down until it reaches the ocean. But none of this works without the people inside. They trained for years. They understood every system, every switch, every failure. When something broke, they solved it. Calm, focused, precise. This wasn't automatic. It was